Have you ever asked ChatGPT a question about your company's internal documents, only to realize that it either doesn't know the answer or confidently gives the wrong one? For example, here we are asking about the hiring process of a company called Agentic Navigator. But since it does not have access to the company records, it cannot provide accurate answer. That's because large language models don't magically know your organization's data. LLM needs relevant data to provide accurate answers. So let's attach the hiring process document as a context. Now we can see that ChatGPT is able to search the document to correctly answer about hiring process. But how about millions of documents? You cannot attach all documents at once because of token limits and cost. So how do companies build AI assistants that answer questions from millions of internal documents? The answer is RAG, Retrieval-Augmented Generation. Hello friends, welcome to Agentic Navigator. Let's have a quick look on LLM. Large language models are trained on vast publicly available data. Imagine your LLM is trained on data like Psychon books, articles, websites, etc. And when user gives prompt like what is photosynthesis, LLM processes the request and provides the answer from the science-related data it was trained on. But if you give a prompt like what is hiring process, which is outside its training data, of course, it will not be able to answer. So how can RAG help here? RAG stands for Retrieval-Augmented Generation. Let's break it down. Retrieval means finding the most relevant information. Augmented means adding that information to the prompt. Generation means the language model generates the final answer using both the user's question and the retrieved context. Now let's see how RAG works behind the scenes to provide relevant context to the LLM. There are two main processes in RAG system. First is document ingestion phase. In this phase, we load the document, split into separate chunks, create embedding, and store those embeddings into vector database. Embeddings represent each piece of text as numbers, so AI can understand meaning, not just keywords. Second is query and response phase. In this phase, user gives query, for example, what is the hiring process? Now RAG system first retrieves relevant chunk from VectorDB, appends this chunk with the user query, and sends this query and chunk to the LLM. Now your LLM will provide answer from this chunk instead of its training data. Now let's understand a complete workflow of RAG system. Although it looks complex, the entire process can be understood in just 6 simple steps. First, document ingestion phase is completed by chunking the document and storing embeddings into vector database. Now query phase starts from step 1, user prompt. The process starts when a user asks a question in natural language. For example, what is our expense reimbursement policy? At this point, the LLM doesn't know the answer because it doesn't have access to your company's document. Step 2, retrieval. Instead of sending the question directly to the LLM, the system first converts the user's question into an embedding. Remember, an embedding is simply a numerical representation of the question that captures its meaning. Using this embedding, the system searches the vector database for documents that have a similar meaning. Step 3. Fetch relevant chunks. The vector database doesn't return entire documents. Instead, it retrieves only the few most relevant text chunks related to the user's question. This keeps the search fast and ensures only useful information is selected. Step 4. Augment prompt. Next, these retrieved chunks are attached to the user's original question. So instead of sending only the question to the LLM, we now send both the question and the relevant context. This process is called prompt augmentation. Step 5. LLM generation. Now the LLM receives everything it needs. It reads the user's question along with the retrieved document chunks and generates an answer based on that context. So the answer comes from your company's knowledge, not just from what the model learned during training. Step 6. Answer to user. Finally, the generated answer is returned to the user. Because the response is grounded in your organization's documents, it is far more accurate, up-to-date, and relevant. But this is only the beginning. In the next videos of this series, we'll cover document parsing, chunking strategies, embeddings, vector databases, evaluation, production architecture, and best practices used in real enterprises. If you found this helpful, please like the video and subscribe to Agentic Navigator for more practical AI content.